All right, so what we're doing now is the 2-1 additional vocab support. So we talked a little bit about this before in the notes. Conjecture is what you think might happen or might be true based on what you've observed. So one conjecture is the streets are wet, so I think it's been raining. That could be a good conjecture, but then also maybe they're like updating the fire hydrant, like releasing the pressure and then making sure it's safe, for the next week or next month, whatever. Or maybe somebody washed their car and that's why the street's wet, or like the water sprinkler. So again, it's just a conjecture. May or may not be true. And then for a counterexample, that definition is a statement that proves a conjecture is wrong. A statement that proves a conjecture is wrong. And so the one they have is talking about evergreen trees because they don't lose their leaves. And you can read through that on your own. But the definition of counterexample is a statement that proves a conjecture is wrong. Okay, inductive reasoning is based on a pattern that is observed. Based on a pattern that is observed. And then their example is 5, 10, 15, 20, etc. So you know the next number based on it. By the way, that's also called extrapolation. It's also called extrapolation. Think of it being extra because it's past the last term. And compare that, I'm just saying, versus interpolation, which would be between two terms. So just introducing you to those words for later on. Extrapolation would be past it. Interpolation would be like, let me do a very simple one. If you know it's 10, 20, then something, and then 40, 50, you can interpolate that it'd be 30. So interpolation would be between. Any questions about that? Okay, then a pattern. The one they used for this one is skipping every other letter. So they have A, C, E, G, I. And so you can figure out, A, B, C, D, E, F, G, H, I. So skip every other letter. Skip every other letter. And then prediction is like a conjecture. It's based on something you think is going to happen. And so my example was on Wednesdays, Bosqueville serves pizza. Next Wednesday they will have pizza. It's a prediction. It may or may not be true. For one thing, maybe we will have a bad weather day next Wednesday. Or like if it were Christmas holidays, we wouldn't have it on Wednesday. Or you could just say, well, maybe the truck, broke down or ran out of a supply. So it's a prediction. Okay, so now let's move on to this. As always, we always do the vocab and reteaching. This is like an extra copy of notes, which you can read through. It's like printed notes. And we'll do these exercises. So make a conjecture about the rule that these follow. So you've got 3, 6, 9, 15. That's a simple one. Basically, you're doing +3, etc. So you could say number increases by 3. Number increases by 3 each time. Number increases by 3 each time. So remember, try both addition and multiplication as needed. If you did 3 times 2, you would have gotten 6, but then 6 times 2 would have been 12. And so if your first one doesn't work, then do your other one. Just try again. Okay, now this one, 9 divided by 3 gives you 3, and then divide by 3, etc. So you can either say divide by 3, or you could say multiply by 1/3. Divide by 3 or multiply by 1/3. Because basically your number in your denominator would just multiply by 3, because your next one would be 1/27. So that's the way that works. Any questions? Okay. Then this is like what was in the vocab support, where you have your B, D, etc. And so this one I'm just going to put skip letters. Could be more specific, but I'm not going to be skip every other letter. But I just say skip letters. Then this one is a little more complicated. Let's look at it a little bit. We got 0, 5, -2, 3, -4, 1, and so forth. So between these, you're adding 5. And between -2 and 3, you're adding 5. And between here, you're adding 5, etc. So plus 5 is part of it. But also you're going 5 to -2. So you're subtracting 7. And then 3 to -4 is also subtracting 7. And from 1 to -6 is also subtracting 7. So your rule is going to be plus 5 followed by -7. So it's a little unique. It's definitely not a linear pattern where it would be the same common multiple. Then this next one, what do you guys think? You got 4, 8, 16. Yeah, multiply by 2. Good. And then this one, you go 0.1, 0.01, 0.001, 0001, etc. So this you could either say divide by 10, or you could just say add a 0 to the right of the decimal. Add a 0 to the right of the decimal. You're getting an extra 0. Divide by 10 or add a 0 to the right of the decimal. Okay. Now the other side of the reteaching. Draw the next figure in each sequence. So we have a line, and then it goes up, and then from that it goes to the right. From that it goes down, and so forth. And so copy this figure. Okay, then it went here and then up. And so on the one that was sideways and then up, then next it went to the right. Sideways, up, and then to the right. So then that's your answer. And on this one, they're filling in squares and adding empty squares and so forth. So you can see the pattern. What we're first going to do is copy this last one, and then we'll look at it after that. So it goes here, there, then back up, then even higher that's blank, and then filled in. So it's not this middle one where it went up. We've got to be back here, and so it goes down like that. By the way, I'm going to introduce one quick term to you. This would be considered the period, because the period is like the start of the repeating pattern. I guess I should put it like right here to line up. Later on, you'll need to know that in trig. Like, for example, when you're doing a wavy line like that, from here to here is considered a period. So either from the middle to this middle, or from the top to the top, or from the bottom to the bottom. So a period is just a distance for a repeating pattern. Any questions? Okay. Now for this one, exercises, find one counterexample to show that each is false. You only have to put one of them. I'm going to put a couple, at least in some cases. All vehicles on the highway have exactly 4 wheels. So, of course, we want to show it's false, and so you could say 18-wheelers. That could be your answer. Or you could put motorcycles. You only have to put one of them, but those are a couple of examples of vehicles that don't have 4 wheels. Is it a dually that has 4 tires in the back and 2 in the front? Yeah, so that's another one. So anyway, I'm not going to keep on writing them, but yeah. Well, how do you spell that?
D-U-A-L-L-Y.
D-U-A-L-L-Y? Okay. All right, thank you. D-U-A-L-L-Y. Okay, that's fine. Then all states in the U.S. share a border with another state. Hawaii, right. Also, Alaska would work because it borders Canada, right. So just whichever one. All plurals end with an S. So, what's that? Deer? Yeah, right. That's good. Or I'll do a math term, radii. It's more than one radius. And then, like, you could also say geese. So it doesn't matter. Just pick one. Huh? Yeah. Okay, now number 12. The difference between 2 integers is always positive. So first let's talk about what an integer means. An integer is a positive or negative whole number. It's not a fraction unless you do like 4 divided by 2, which could be reduced to 2. So an integer is a positive or negative whole number. The difference between 2 integers is always positive. Well, let's do some examples and see what we come up with. So if we do 4 minus 2, that's 2, which is true. If we did 2 minus 2, that's 0. So 0 would be considered neither positive or negative, or nor negative. So this could be one of your answers if you want to. Or you could say 1 minus 3 is negative 2. And, negative 2 would be negative. It's not positive. So basically when you subtract things and get either 0 or a negative. Any questions? Okay, so then this says all pentagons have exactly 5 congruent sides. So what the regular pentagon looks like, regular meaning perfect because all the sides and angles are equal. A regular pentagon would look like this. where all of them are marked as equal. But all of them are not like that, and so you could just think of a house. If somebody's drawing a house and then a pointed, triangle roof. So that would be considered irregular. Because you could have 90 degrees and then you could have 2 obtuse angles and 1 acute. So it's all random. Instead of like all of them being, in this case, I don't need to show off, but I don't mean to. But this is all 108 degrees. Like in a hexagon, it's all 120s. You don't need to know that yet. I mean, I'm just saying what it is. Any questions? Okay. Then this says all numbers that are divisible by 3 are also divisible by 6. So what we mean by divisible is you divide and then the answer or quotient is a whole number. So, for example, if you did 3 over 3, that's 1, and 6 over 3 is 2. So those both work, but if you say 3 divided by 6, that'd be a half, which is not divisible, in other words. So dividing by 6 is one answer. Dividing by 15 would be another answer, because you can do, well, I think I put it backwards. 15 divided by 3 is 5, but 15 over 6 is not divisible. So I really ought to put dividing by 6 or 15 are examples. And of course 6 over 6 was 1. You don't have to write that. But if you divide by the bigger one, or if you divide by 15, it works for one of them but not the other. Okay, all whole numbers are greater than their opposites. So a whole number would be a positive integer. I'm going to define it that way. It's basically like a counting number, and now you're going to get the answer, 0. So a whole number includes 0, and so 0 is not greater than negative 0 because there is no such thing. So 0 would be your answer. You know, 1 is greater than negative 1, a million is greater than negative million, but a 0 is not greater than 0. Okay, number 16, all prime numbers are odd. Well, one of the very first ones is 2. Because it goes 2, 3, 5, 7, not 8 or 9 or 10, but then 11, and so forth. So most of them in our list were even. Were odd, but 2 is even. And of course you skip some odds too, like you skip 9. So anyway, any questions on that? Okay. Then this is the puzzle code breaker. So see if you can decipher the pattern and add the next 2. It says the National Defense Organization is looking for new recruits skilled in code breaking and pattern finding. So you got -1 going to 2, 2 to 5, 5 to 8. So that one's kind of simple. What do y'all get?
11.
Yeah, 11 and 14, because you're adding 3. Perfect. Now this one, the easiest way to think about this is think about a clock. Like an old-fashioned clock, not a digital one. So it's pointing here, and then it's pointing down, then it's straight, and then it's over here. So then the next one would be up here. And then, just like at 12 o'clock, it'd be straight. So like you can estimate this one to be like 2 p.m. You don't have to write this, but 2 p.m., 4 p.m., 6 p.m., 8 p.m., and it might be 7, I don't know. So 9 would be flat, so either 10 or 11. I'm just going to say 10:30, just to be different. And then 12. And it could be a.m. or p.m. So you don't have to write the times, but that's the way the analog clocks worked. Okay, so this one we go from 2 to -6. One way is by subtracting 8, but then that wouldn't work for this. And so what are we doing?
I'm doing by -3.
Yeah, times -3. Perfect. And then that works for here and here. So 54 times -3 gives you 162, and then times -3 gives you -486. So just use your calculator for that. A negative times a negative is a positive, and then times another negative. And then this one is your months, apparently. January, February, March, April, May, June. So this is your months. And then this one, let's count the sides. I get 10 sides. And then I get 9 sides. And then this, you know, is a stop sign, so that has 8. And then this has 7. So then we need the 6 and the 5. So the 6 is the hexagon. So you can draw it like that. So I have my top and bottom parallel, and these just make an angle. That's the way I did it. And then we talked about a pentagon. It tilts out a little bit instead of being vertical, and then it makes a point. Okay, then this one is the challenge one. Looks like a Rubik's Cube a little bit, sort of. You go here, and then there, and there. I'm not that good at this one, so I'm just going to show this. Does anybody have a guess where it is? You do? The bottom left?
Middle left.
Okay. Yeah, right. Okay, so the bottom left and the middle left. So the drawing for that looks like this and that. So y'all were exactly right. So the missing square rotates clockwise around the outer edge of the 3x3 grid. I should have left a spot, really. Oh well. I'm going to color in all the rest, because to me that's easy. That's my accommodation. And then for the middle left, like that. Okay, so that's the end of the video. Now you can work on your Math Excel.